Hello, it's Duncan. I know I keep saying that this is going to be the last episode in our error handling and refactoring, but this time I really think it might be true. So let's have a quick review and then we can crack on. So the ways our software can go wrong starts at the very sort of bottom here when we're creating an item, and we express that in an exception that we throw here if the quality is less than 0 or the name is blank. And we quite cleverly reused both a sealed type and an exception here, so that we could marshal information from here up into our constructor, this invoke on the companion object, where we catch exceptions and we return an error type. So our construction returns a result of either the successful item we created or why we couldn't create one. And then when we go and use those, well, here, for example, we can map that into couldn't create item type with the failure inside it. And there are other ways that we could fail to parse our stock list, and we have a set of failures there. So this hierarchy here is stock list loading errors. So as we're going out through the layers, we have an error type per layer, really. Stepping up one more, we have this flat map that allows us to take an error type and combine it with another error, with another thing that might fail, which is this updated and saved to, and that then produces another result. We step up then, and finally we're here where we may or may not succeed in listing our stock. But if we do fail, then we just throw an exception at this point. And if you've been following along, you remember that our aim is to get more information about what failed into our logs, rather than just this error could not load stock list. So let's write ourselves a test to see what actually happens at the moment. We have list stock tests. It's going to be a little bit difficult to arrange, so I'm going to duplicate ourselves another test function. I'm going to say something about handles errors, maybe reports errors. Inline that's not important. Now we suspect that at the moment we get an internal server error, and that was from the filter that catches any exceptions that leak. So let's see what our current state of play is. We need to make this fail somehow and have the fixture, and that has a stock file. So if we were to mess with the stock file that's been created by a fixture, we could force an error. So if we were to read the text from that and then replace, now what's going to be in our stock file, we can have a look and see what we're creating it with. And the answer is some bananas, well, a banana. So let's take that banana and let's replace the banana in our stock file with a blank. And we know that blank names aren't allowed, so that should cause an error. And then we're going to say this dot stock file dot write text. So what we're doing is when we create a fixture, it writes a stock file. Then we are taking that stock file, munging it so that when we do read it, when we hit our root, then it will fail. It's a little bit nasty, but it will do, I think. So let's run all our tests. Okay, so we have this test fails, and the reason it fails is, so we did have some sort of result. We've got this approvals tests, and so we can have a look, see what ended up in there, and that's this, something went wrong, sorry, and that something went wrong, sorry, is what our catch-all filter at the very top level says if it catches an exception. So we can see that the result we're seeing is because we caught an exception, and the exception that we're catching is the one from listing here, this error. Okay, what I'd like to do now is prove that we're taking a different path through the code. So I'm going to approve that file so that if we run this time, it will pass. And then I'm going to say, if we have a different message in there, then if we put that different message in the new code path, we'll know that we took that code path. So now we've got a failing test, and let's just take that string, and in our listing, we'll say instead of on failure here, we want to return a response with a 500 and that message in it. Ordinarily, we would just say return response with a body of that thing. But this is a lambda and we can't return out of a lambda, which is a bit of a problem. So let's take the opportunity to learn a little more about other ways we can look at errors. I'm going to comment that out so I've still got it. And now let's look at what we can do with that stock list. We can say when stock list. The stock list, if you remember, is our result. And that can be one of two types. It can either be success. So we can say when the stock list is a success, then this is what we want our response to be. And if it's failure, then we want our response to be this thing here. Right. Small problem that, I'm going to reformat, make sure we've got everything in the right sort of import. Not that one, that one. And now the only problem is that here, this stock list is still a result, but because of flow typing, we know that it is a success. And so we can say stock list dot value. Okay. So that's the hand-rolled way of dealing with result for k error types. Let's run that and check that it all works. Oh, it almost does. And it works, it seems, all but a line at the end. So let us just reapprove this to say we don't really care about that. Run again. Okay. So now we have a test in place. Now we could recast that in terms of map and recover, but I think it's quite nice. And personally, I find it really easy to read. You say when the stock list is something or it's something else. We can just make this the subject and check that still passes. Now then, what we'd like, though, is not just an exception, not just this body, but we'd like to be logging something. And our logging idiom is our analytics. So this list handler is going to need an instance of analytics to report this issue to. So if this had analytics, then as well as returning the response, we would be able to say analytics. Remember, that's a function. And it takes an analytics event. So we need an analytics event in here. And we need to say, well, what is the failure? The failure is our stock list reason. And we'd need to make that into an event. This point is probably worth naming this not just stock list, but stock list result. Okay, so we want to convert our reason here, which is, can't see the type, but the type is stock list loading error, to an event. We could add this function, or we could just say, well, what if our stock list result reason was an event? Then that would compile. And in fact, IntelliJ will offer to do that for us. It will say, let stock list loading error extend analytics event. Try running that. And we've forgotten to put the block in. Now our list handler needs to know about the analytics, but luckily we have one lying around when we create it. Yeah. Okay, that passes, but we haven't actually shown that we called the code. So we should probably previously have looked into our tests here and said something about our analytics. The fixture contains some events. So our first event, say assert equals And what should it be? Well, we want it to be our stock list loading error given a item creation error of blank name. A little bit of import. It's not just a stock list loading error, it is a couldn't create item error. There we go. Right, let's see whether that is true. And it isn't. And that's because, in fact, we need to do this after we've made the request. So it's this request, asking the routes to process the request, that makes the events happen. So we'll do that. Let's try that. Splendid. We're not quite done though, because one of the problems with our analytics is that it relies on Jackson to convert analytics events into JSON. And I think if we look in here, we'll see that, maybe not there. What we'll do is we will run just this test and see what ends up in our logs. There we go. So let's have a look. And you can see here we've got the event that we're seeing here, but in our logs it's being rendered as an exception. So we're ending up with stack traces and all sorts that are no real use to us at this point. We didn't really throw an exception. Well, we did throw an exception, but we don't want the stack trace to appear in our logs. It's no help to us. So what we're seeing in the log here is Jackson's rendering of this event with this item creation error inside it. And that item creation error is an exception. And so we're getting all of the fields that are inside an exception. Okay, what can we do about that? Let's go back then to item and say, this is caused by these things being exceptions. That was expedient at the time, but I think maybe let's back that out. But we still need to throw something. So let's give ourselves an item creation exception in here. So now we have an exception. We can make these not exceptions. And when things fail, we will throw the exception with the error inside it. That means that we can catch the exception here. And because we know that that is the only type of exception we expect. And then we can say failure with the X is error. Now we'll run all the tests to check that hasn't broken other things. And then we'll run that specific test to see what ends up in our logs. Okay. And now you can see here our event is reason is an empty object and the event name is couldn't create item. To remind ourselves where that event name comes from, it's because the stock list loading errors are now analytics events, and analytics events have an event name default method on them. So that's how this event name gets in here. This empty object here is not very nice, so let's see if we can fix that. We can solve the problem of our empty object a similar way. If we take this from here and go back into item, then we can give every item creation error a field that will end in the logs, and we can call it error name. Similarly here. And now if we run, in our log here, we end up with the reason error name is blank name and the event name is couldn't create item. We'll just tell the compiler that we do actually need that. Now, what we've ended up doing here is changing code in item to help it deal with other aspects of our application, in particular, the actual implementation of our logging. That may or may not be a coupling worth making. I think for most code bases it probably is, so I think we will leave it in place here. Let's run the test one more time and check that everything still works. Let's just review those changes as we check in. We added a test here to show that the error handling code works, which we really nastily had to mutate our stock file. If we did a lot of this, then we might need a better abstraction, maybe some mocks or something, but this will do for now. We're only testing one of the types of failures that we could get, but we're reasonably confident that if we do one, we do them all. Stepping up in our roots, then we pass the analytics into our stock and our listing itself. So up into our roots, we pass the analytics into our handler, and our handler now switches on the type of loading the stock list, and if it gets an error, it talks to the analytics to tell it about the error, and it returns our internal server error. And this works because we have changed our stock list loading error to be an event. Certainly in the higher levels of the code base, it's a really nice trick that both reduces the amount of code you need to process and report errors. So let's check that in. And this is report errors to analytics. Found to be some issue in the analyzing. One warning. Always the import and commit. Now this finally is the point at which I think I'd be happy to push to production, because we now have both uncaught exceptions caught by our uncaught exceptions handler, and expected errors returned are being logged with the analytics as well. Now I have one last trick up my error handling sleeve, and that is a bit of an HTTP 4K hack. And it comes about through thinking about what a response is. An HTTP response is really rather like an error type. We either have a response with these OKs or the 200-like statuses, or we have responses like internal server error that are saying we can't succeed. So we have either success or failure, like our result type, either stock list or stock list loading error. What I'd like to be able to do is to pass the actual failure, this error, up with our response so that it could be handled at a higher level. Another way of looking at that is that this list handler isn't really a pure function, because these analytics, we have side effects on these analytics. So we're calling these analytics for its side effect, that it populates our logs, but it would be nice to make this a purer function to move our side effects up. So what we might like to say is that in the case of failure, we don't do the analytics thing here, but instead we set some sort of thing. We might say our response is internal server error with error. And that error would be our failure. So it would be our stock list, result, reason. And you'll see here that IntelliJ is offering to import a with error. And that's because I've just written one. So let's go and have a look at what that does. What we'd like is that our HTTP response had a little map of things we could add to it and get out at the other end, but it doesn't. But we can fake that with some sort of lookup. And that's what this response errors import does. And there's an object here, response errors, which allows us to bring this extension function into scope. So here, by importing this response errors with error, we're able to use that as if it's an extension function on response. Well, it is an extension function on response. Now, if we run that, it will fail because we're not pumping anything down to our analytics. But response errors comes with a report to, which is a filter. So as we did with our catch-all filter, we can go to our roots and say, then response errors dot report to our analytics, and then whatever's next in the chain. So let's try running that. And that passes, which means that our analytics is now logging details of our errors. This means that we don't need our analytics down in our list handler, which simplifies things there. How can we get rid of this? Check that still works, which it certainly should do. Let's go and have a look at the implementation of the filter. That asks the next thing down the line to process a request, and then sees whether it has a special header. This special header is set by with error here, here, and this then uses the value of that header to look up in this map. So we've got a single map. This is a way effectively you can add properties to an object that doesn't already have them with extension functions and lookups. Normally we might use a thread local for these sort of things. It's complicated in HTTP4K because we don't mutate response objects, we create different ones. So we need to set a header in order to recognize that one response is derived from another or another. Okay, finally then go back into listing, and it's a little bit of a pain to keep on doing stock list result to value and reason and so on. So we can recast this as our map and recover. I'll do that by hand really. I think we'll say this is, take the listing, map that, which is our stock list, into response OK. And if that fails, then we can recover with this response. And we don't need then to get the value out because the map will do it for us. And we don't need to get the reason here because that is it, which we might rename to be error. So now our handler says, I'm going to try and get a listing. If that succeeds, then I'm going to respond with OK, asking handlebars to render some view model for us. And if it fails, then I'm going to set an error into our response for the filter to pick up and log for us later. Now this is almost certainly overkill with only one handler, but as a pattern it allows handlers to process errors in a consistent way. They all just have to say with error and know that our infrastructure, the roots here, will look after us. Check that in. So this is use response errors filter. One last run of the test for luck, and I think we are done with error handling in the Gilded Rose application for now. If you've been with me for the whole journey, then well done. Thank you very much. If you have, then I suspect you've enjoyed it, in which case you should definitely hit the like button and subscribe to the channel to see more content like this. There's a lot more content like this in the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the description text below. Thank you for watching.